Your entire project is Newton's 3 laws of motion, but there was lots of words in there that were kind of confusing to folks. So we're going to be working to unpack and give you details about some of those words. Can you measure motion without talking about time? Yes or no question. Talk to your table. Can you measure motion without talking about time?
No.
So I'm hearing no on this side. What about over here? Can you measure motion and not talk about time? So here you measure motion and not joking. Can you measure motion and not talk about time? Time and motion go together. Okay? So what's the shortest, so some things move super fast. What's the shortest amount of time we can measure right now? Nanosecond. Awesome. 1/billionth of a second. We don't currently have any equipment. Can things move faster than that? Oh yes. We just don't have a way to measure it. Eventually. So what is motion? You can think of motion two different ways. Motion's a way to describe how fast something's moving. That's kind of like the layman's definition. More scientific definition, motion is the condition in which one object's distance from another object is changing. So on the left-hand side, you put motion. On the right-hand side, you could put all of that in one box, or you could put it as two. Because the top one's kind of the layman's definition. The bottom is more scientific-y, to use Chesser's word. I love that word, scientific-y. It's me coming up. So, can you describe motion with only one object? Think about that for a second. Can you describe motion with only one object? Kind of whisper at your table. Come up with a conclusion. If you only have one object, can you describe motion? It's not a trick question, I promise. So, can you describe motion with only one object? She said motion.
Oh, yes.
Oh, well, now you're changing your answer.
Actually, no, it's two.
Can you describe motion using only one object?
Yes.
Okay, so we're saying yes over here.
Oh, wait.
All right. I don't think over here. Can you describe motion using only one object? Whoa, real definite about it. Nope.
I'll use one object.
I wish you watched it right there. To this side. The way you feel like I should see it. Can you describe motion using only one object? Because over there's pretty active. Nope. Shut up.
I don't care.
There's only one object. What about up here? Can you measure motion with only one object?
Hi.
I'm like, camera loves me.
Can you measure motion with only one object? Yes. We'll come back to this question at the end, because I am hearing some people are definite, yes you can. They're like, no. We'll ask you when we get to the end of class. Distance gets misused by Hollywood movies all the time. Hollywood people get signs wrong so often, it's annoying. And then people think, oh, it's in the movie, so it's really true. Distance and displacement are different. So on the right-hand side, you're going to have the definition. On the left-hand side, you're going to put the word distance. And on the right-hand side, the definition of distance, the total length of the actual path between 2 points. Then you're going to go down to a new box. You're going to put displacement. Displacement on the left, definition on the right. Displacement, the length and direction direction of a straight line between starting and ending points. So if back there at the camera is a water fountain, and I've watched how you guys say, oh, I'm gonna go to the water fountain, can I get a fast drink? Here's how you folks walk to the water fountain. Well, you go over here and you say hi to this person. Oh, hey, how is it going? And all of a sudden you see somebody over there and you're like, oh, wait, yeah, I forgot to tell you in history class, remember we've got to, and you're still going to the water fountain, which is back by the camera. And then you come over here and you're like, oh, yeah, I forgot to give you my phone charger. Let me hand that to you. And you eventually wind up getting to the water fountain. Did you walk distance or displacement?
Displacement.
So let's look at our definition. Total length of the actual path between 2 points, length and direction of a straight line. So do most junior high students walk going to the water fountain, distance or displacement? Well, let me, so most adults, when we need a drink, there's the water fountain. Oh, you need to talk to me, walk with me, I'm headed towards the water fountain. So is the adult walking distance or displacement?
Displacement.
So let's kind of color code your notes a little bit. Let's look at what the key words are in this definition. Keyword in distance definition, actual path. So you might want to go to your notes and highlight or change the font color where you put down the definition of distance. Actual path is your clue. Displacement, the clue words are straight line.
Distance. Distance, well, is simply going in one direction, and displacement will be going in different directions, and also going to be
Now let's look at unit definitions. Which one's the straight line, distance or displacement? So junior high kids, on your trip to the water fountain where you're going over here and hand somebody a phone charger,
Oh, yeah.
and you see somebody over there and you're like, oh, hey, wait a minute, I forgot to tell you something in history class.
What?
Is that distance or displacement?
Displacement.
Look at what you highlighted, what you changed the font color on.
No, distance. It's distance.
Here's how adults walk to the water fountain. There's the water fountain, I need a drink.
That's
You need to talk
displacement.
to me.
It is displacement.
That's displacement.
All right, let's go kind of a visual aid. Okay.
Displacement is a straight line. Distance is the
So
path.
here's a cartoon showing just what I did. So the adult and the little kid are ending up in the same place, and they started off the screen. So they started over there next to the fire alarm, wound up in the same place. Who walked distance? The little kid or the adult?
Kid.
adult.
Kid.
So in your notes, on the right-hand side, in a new box, put down from the cartoon, so that this will refresh your memory. From the cartoon, the adult walked. What do you think's the answer? From the cartoon, the kid walked. That's your answer. We'll check in the hour. Make sure you got it right. That's how you would take notes, so that those definitions and things don't always make sense when you're just writing them down. You need some examples. So you add into your notes on the right-hand column, in the cartoon, the adult walked, say distance or displacement. In the cartoon, the kid walked, tell me distance or displacement. We will come back to that for an answer. So it says speed limit 55. 55 what?
Miles per hour.
But if you were in Europe, would it still be 55 miles per hour?
No.
Kilometers per hour. So what's speed? Is speed the same thing as distance and displacement or something different? The distance an object travels per unit of time. So you would have speed on the left-hand side. On the right-hand side, your definition. Distance an object travels per unit of time. A lot of students, and and I'm not calling anybody out, when you were looking at unpacking the NGSS, that phrase specification of units, you were kind of lost and confused on. And it's talking about units in this definition. The distance an object travels per unit of time. That sign is saying a unit of time of an hour. If you run field and track and you run the 200-meter relay, how is your distance and speed measured? Seconds, so a different unit of time. If you lived in Europe, we already said that would be kilometers per hour. If you were measuring how fast atoms move, would it be an hour for your unit of time?
Nope.
Probably millisecond or even a nanosecond. So in the NGSS, where it was talking about specification of units, will your entire project have to have 1 unit of time?
Yes. No.
Yes. So that phrase that a lot of students were getting confused on in NGSS, this is what it's talking about. So one person in your group can't do part of the project and do measurements in inches, while another person at their home builds the second part of the project and they did it using the metric system. That's what it meant in NGSS about specification of units. One of you can't measure how fast your car was traveling when you built the car and crashed it into something in meters per second, and somebody else measured it in meters per milliseconds. That's all it was talking about on your project instructions about specifications of units. Your entire project, you all have to decide what units you're going to measure both the items in and measure speed in. That's all it was talking about for that part of the NGSS. Speed, and I heard somebody say it, distance divided by time, not new. Should have covered that in math class a year or two ago. Right? You covered this in math class. Distance always goes on calculator first because it's on top. They covered this in math class, correct?
Not yet.
Seriously? Didn't they cover it like in 7th grade?
Well, I
6th grade?
suppose I wasn't in the 7th grade. But yes, we have been looking at ratios, yes. And these would be functions of rate to time. This is what we're talking about, rate. Your x-axis is going to be your time almost always, and your distance will be on your y-axis as your input and output. It is what we're talking about. That's why you need to know if something is a function, so you can compare it as rate to time.
Math and science, they are best friends.
The physics especially.
So hopefully that helps some of you on figuring that out. So here's just some useful fun speeds. Fingernails grow about 4 centimeters. Somebody needs me to go back. So your fingernails grow about 4 centimeters per year. Most people walk about 3 miles an hour. That's their speed. Driving speed now in the United States is many places 60 miles per hour. The Earth is revolving at 30 kilometers per second, and light moves at 300 kilometers per second. Just some interesting speeds. There's 3 different kinds of speed, though. Again, please get it wrong. So make sure you understand the standard speed, distance divided by time. Okay. There's the ones I was just reading off. And you've had these kind of road problems. You know, Johnny drove to Little Rock and it took him 4 hours. Distance to Little Rock is 150 miles. What was his speed? They're talking about average speed. So if you ride your bike to school, do you go at the same speed for your entire trip from home to school?
No.
No. Why? It might be hill. What else?
What was the question?
If you ride your bike to school, do you travel at the same speed for the entire journey?
No.
Somebody
You
said
travel
might
at
be
an average
hills, somebody else
speed.
said might be cars, might be curves. Moving moving objects do not generally move at a constant speed. Math term, constant, what's that mean? Is it changing or not changing if it's constant?
Not changing.
Not changing.
Since the
Moving
word
objects,
constant.
few, are generally not moving at a constant speed. Their speed is changing. Because you got uphill, downhill, you got curves, you got traffic, maybe you have a pedestrian walking in front of you. So you're really talking about average speed. The total distance that the object traveled divided by the total time, which was the example I gave you of Johnny drove to Little Rock, which is 150 kilometers away in 4 hours. That's his average speed. I am sure there was times that it was flat open road and he didn't see a police, he was doing more than 50. There was also going to be times he's driving through a city, hit a stoplight, and he's doing 0. So that's finding average speed, which is not the same thing as speed. That's the standard word problem that you run into thousands of times throughout school. But what's instantaneous speed? Is that the speed you can move in one instant of time? Or is that the speed at that exact instant when you look and you measure it? So talk at your table. Is instantaneous speed how fast you move in one instant of time? Or is instantaneous speed your speed at that exact instant when you look? Well, that's tight. Then I'm going to have to give you some answers. So if you think instantaneous speed is how fast you move in an instant of time, please stand up. If you think instantaneous speed is how fast you move in an instant of time, please stand up.
What's the other choice before I stand up?
Okay. Interesting team. So if you think instantaneous speed is the speed you're traveling at any given instant, like the instant you measure it, stand up. You gotta make a choice.
What?
If you think instantaneous speed is the speed you're traveling at the instant in time when you measure the speed,
No, that's number 2.
I see a lot of hesitation.
It's number 2.
See a lot of
What's
faces
the second
going
option
up.
again?
It's the second option.
That's the only option. If you think instantaneous speed is the speed you're traveling at the instant you look, you should be standing up.
First option?
Congratulations, if you stood, you are correct.
Do it all the time.
Instantaneous speed is not how fast you can go in an instant, because that is not a scientific measurement. Instant is not a science measurement of time. It's not a unit of measure. Instantaneous speed is in that instant of time the speed you're traveling. So when you glance down at the speedometer when you're driving with your parents, it should probably not be saying 70. Your parents might be having a heart attack. Does the speedometer change as your car is moving? So is your speed changing? It is, yes. I see some heads nodding, yes. The instant you glance down and then glance back up the road, that's what your speedometer is giving you. It's giving you your instantaneous speed. Not how far you traveled in that instant, not the speed in the instant your eyes looked at the speedometer. The instant in time when you looked at the speedometer, that's instantaneous speed. And that's another one that Hollywood movies, yeah, they don't use those terms right. So reference point. Can you measure motion without a reference point? No. I hear a no. So let's go back to the question I asked earlier. Can you measure motion with only one object? Yes. If you think you can measure motion without a reference point, stand up. If you think you can measure motion without a reference point, or you can give me a thumbs up if you don't want to stand. If you think you can measure motion without a reference point, thumbs up. So everybody's telling me you have to have a reference point. So can you measure motion with only one object? You think yes, thumbs up, or stand. So does it take two objects to measure motion?
You can use one object.
Explain how.
Huh? You can measure motion with one object.
Remember in the MDSS it talked about frame of reference? It used the phrase reference point. So let's look at what those mean. Reference point is the point the motion is measured against. So you have reference point, a two-word term on the left, and on the right your definition. A point that motion is measured against. Usually it's a stationary object. Not 100% of the time. Usually it's a stationary object. So if the definition of reference point is the point that motion is measured against, must you have a reference point to measure speed? Yes. Must you have a reference point to measure motion? Yes. So you might want to add that in on the right-hand column. Must have a reference point to measure motion. Must have a reference point to measure speed. So here's a science teacher. With a little video that he made. This last hour. Computer hates the projector. They don't talk with it. All right.
First point. So we're on E here. I got a rubber duck. See this rubber duck? And we're going 35 miles an hour. We got the rubber duck. Now this rubber duck, I'm going to go ahead and throw it up and catch it. I'm going to throw it up and catch it. So my first question is the rubber duck in motion?
Yes, it's going.
Is the rubber duck in motion?
Because it has to move with the open.
Anybody, yes, anybody think no?
Nope.
So everybody's saying the rubber duck's in motion. How do you know?
Because it goes. Because it has to follow the car's motion.
Am I moving right now?
Yes.
Are you moving right now?
Yes. We can never stop moving.
So, I'm
Heartbeat.
hearing some say it
Heartbeat.
can. What does it depend on? Your reference point. If you were standing on the moon and had a high-powered telescope and you were zooming in on our class, are we moving?
Yes.
The Earth is moving.
There's no way we can stop moving.
Exactly. So is the chair you're sitting on moving? If your reference point is space, yes it is. If your reference point is me, is your chair moving?
No.
No.
If your reference point is me,
Yes.
well, only because you're over there moving your chair.
You're standing still.
So you're seeing, you're kind of getting the idea here of how motion changes based upon reference point. Let's keep looking at the science teacher in just a minute.
And the second question is, why use the reference point, the rubber duck?
Reference point.
Would it be my hand? Would it be the steering wheel? Would it be this window? Would it be the
He's not actually turning the car, it looks like. Looks like he's just parked in his car.
More. So what's the reference point for the rubber ducky?
Hand.
For the man.
Steering. Driver's side window. Oh, window.
Okay,
No.
so
Tree outside the car. Yeah.
let's go back.
Well, you know, just in case the camera can't see.
So talk at your table for a second. You all watch the same video. For the rubber ducky, what was the reference point? Hand, steering wheel, driver's side window, front windshield, or the trees that were going outside of his window?
All you need is a feet.
What's the rubber ducky's reference point? Well, let me talk for a second. Some of you are like, I got it, Disney. And some of you are like, I have no clue what you're talking about. You're speaking foreign language again. I didn't understand none of this. So what do you think is the reference point? He says all of them. What do you say? What about over here, ladies? What's the reference point for the rubber ducky? Only for the rubber ducky. His hand, okay? And why do you say his hand?
Because
That's what made the duck go in motion. That's pretty valid. All right, so King, you said hand. Why?
Because, like, whenever it's in the car, it goes up, but then it, like, also, in the video, you saw it go back a little bit, and he had to move his hand to catch it. So it's
Okay, move his
going,
hand to catch it a little bit.
it's going up, and it's going forward, but not at exactly the same speed as the car, so it goes back a little bit.
So the duck's going vertical, correct? Everybody
Yes.
agree that? Was it
And
going lateral, meaning side to side?
No, it's not vertical, it'd be diagonal, because it has to move with the car, too.
So moving the car. Because the car's moving.
Because if it were just vertical, then it'd go,
So he'd be leaving the duck behind.
so it has to
The
move
duck wouldn't be in the
diagonal.
car anymore. So the duck's moving mostly vertical, but also some lateral.
Also, you have to count on wind resistance.
What's the reference point for the rubber duck?
Wind resistance. See, also, air conditioning.
Hand again.
That could have also made it go back.
What do you think? Make a
You
choice.
have
Window. Okay. When I first watched it, 3 years ago, I guess, my first thought was it was the hand. Because to me, his hand didn't seem to, once he released the duck, really be moving. So when I first watched it, I thought it was his hand. Somebody else has said the window. We've got some folks who are saying everything. What do you think? What's the reference point for only the rubber ducky? The trees. Ladies, what's the reference point for the rubber ducky? Why are you looking at her? So they're still discussing it. Ladies, what's the reference point for the rubber ducky?
Because it's still.
How dare you?
Okay. So let's go back. Can you measure motion with only one object, yes or no? Can you measure motion with only one object? No. Even if the other object is just a point location, meaning your reference point. So which of these is the reference point for the rubber ducky? Could it be more than one? Could it be two of them? Yes? No? If you said it was his hand, could it also be the steering wheel, which was moving a little bit, but he wasn't making major turns? Yes, it could also be the steering wheel. Could it be his driver's side window? It wasn't moving, and he wasn't rolling it up and down. We're not talking about the objects outside, that's the tree. He wasn't moving his window up and down, it was staying in its stationary position within the car. So could the reference point be his window? Why not? So,
Was it affecting the boat?
oh, okay, well, that's an excellent point. It wasn't affecting the duck. His hand affected the duck. It didn't hit the steering wheel, so did the steering wheel affect the duck? No. Did the tree outside the window affect the duck? Definitely not. The reference point could be any of those. Those folks over here that said any or all. So it depends on how your eyes looked at that video. When I looked at it, I was using his hand as a reference point. Second time I looked at it, I was looking at the trees flying by. So if I was looking at it for the trees flying by, is that my reference point for the duck, the car, or both?
Both.
Well, how's it both? The duck's in the car. So the trees flying by could be a reference point for both the car movement and the duck's movement. So going back into those standards that you're supposed to look at for NGSS, remember where it talked about, remember where it talked about frame of reference. So if two people are working on your project at the same time in two different locations, will you both have to be using the same idea of reference point and frame of reference for your project to make sense? Yes. So you're going to have to decide that before you actually go out and build it, correct? Yes. You're also going to have to decide what unit of measurements are you going to be using before you work on your project. Some people have been talking about that they were going to blow up some fruit. It's kind of full again.
You know what's a really waste of paper?
So when you're measuring the motion of the fruit, if each of you try this experiment at your own home, and then you're going to compare as your project, make certain that you're measuring the motion of the fruit in the same units. That's all that it meant when it talked in NGSS and said specification of units. Everybody who's working on the one project has to use the same measurements. Now, would this table group have to use the same units of measurements as the table group over there? No, you can, each group could have different units. That's why it didn't give you an exact unit. That's why in NGSS it just said specification of units. Within your group needs to be certain you're using all the same units and that you're using all the same reference points. But the different groups might be using different units. All right, I think you have about 5 minutes. Make sure you've got a good understanding in your notes. Distance and displacement. In the cartoon, did the adult walk distance or did the adult walk displacement? Which one's the straight line? Displacement. The adult, so you might go back to your notes if you left that blank. The adult in the cartoon walked displacement. The little kid who was going over here and then was headed over here, was he doing distance or displacement?
Displacement. No, distance, sorry.
Distance.
I got
So make
confused.
sure you go back to your notes, and you might want to add that in. You got, 4 minutes? You might talk at your table about your projects and how maybe you might want to change something now. Or if you've already started building or constructing things, make sure everybody who's building is using the same units. Because otherwise you're going to mess up your projects. Make sure you give a name to your notes. You might call them motion. If you have different notes than other people in your team, you might want to see how your notes are different. Maybe your teammate wrote something down a little bit differently. And then the history teachers wanted us to again stress, History Day is less than 2 weeks away. Make sure you're on target with whatever you're supposed to be doing. Math also had a quiz this week. If you didn't do well, make sure you follow the instructions or talk to the teacher about a redo. thank you. Mr. Chester's second period class on Moodle, he has not yet put on Moodle for you to turn in unpacking in GSS. He's homesick, so I will email him. So if you have Mr. Chester for second period, you have not yet been able to turn in GSS unpacking. You might want to go back to it if you haven't turned it in and change what you put down where it said those words reference point, using today's information so that it makes more sense to you. I'm sure he'll have that up by tomorrow. Just keep it in your Google Doc. If you have me for second hour, unpacking in GSS is listed right underneath the planning document. So when I go home tonight, I'm going to be doing grading.
Yay.
You need to turn in group contract, planning document, unpacking in GSS. If you turned in one of those and you're like, oh man, I screwed it up, if you want it back to fix it, you have to email me. The only way I can send it back to you as a draft is you have to email me and I have to go in and change some settings. So if you've turned in one of those and you realize now that you messed up and you want to fix it before I grade it, send me an email, tell me which assignment you want me to send back to you, and I will give you an opportunity to fix your mistakes and improve it before I grade it. But if you don't email me, tonight when I sit down, I'm going to grade whatever you've turned in and do it. If you have Mr. Chester, you can't yet turn in the unpacking in GSS. It'll probably show up in the middle tomorrow. I think so. Sick. And doesn't class end at 2:30?
Yes.
All right, my phone says you got 1 minute to fetch your stuff.